Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. On this video I will do a demonstration on building a switch network with the redundant links. This is lab 2.1.2.10 with CCNA 3. Okay, so this is the lab that we're going to do, 2.1.2.10. Building a switched network with redundant links. For this lab, we need 3 switches, switch 1, 2, and 3. And this is connection. So I'm just going to go to my connection to my switches. So I'll already got a connection to my access server. Okay. Show session. I'll go connection to switch 1, 2, 3, and 4. We don't need switch 4, we just need switch 1, 2, and 3. So I'm going to go to switch 1. So switch 1 is already just booting up. Or rebooting, I should say. Right, so let's just, while that's happening, let's look at the objectives and the background and scenario. So objective is to build a network and configure basic settings. Part 2 is determine the root bridge. Part 3, observe spanning tree protocol port selection based on port cost, and observe spanning tree protocol port selection based on port priority. Background scenario. Redundancy increases the availability of devices in network topology by protecting the network from a single point of failure. Redundancy in a switch network is accomplished through the use of multiple switches or multiple links between switches. When physical redundancy is introduced in the network design, loops and duplicate frames can occur. The spanning tree protocol was developed as a layer 2 loop avoidance mechanism for redundant links in a switch network. Spanning tree protocol ensures there are only one logical path between all destinations on the network by intentionally blocking redundant paths that could cause a loop. In this lab, you or we will use a show spanning tree command to observe the spanning tree election process of the root bridge. We will also observe the port selection process based on the cost priority. Okay, so for this lab, we're going to need 2960 switches. We are using some 3560s as well, switches with the highest IOS. Okay, resources required, we already have that. Console cables, we already in the switches, and Ethernet cable as shown in the topology. Well, the Ethernet cables are not exactly as is in the topology. It's not connected to port 1 and 2. We'll find out very soon. So part 1, you'll set up the network topology and create basic settings on the switch. So we need to cable it, which we did. Initialize and reload the switches. As you saw, the switches will reloading, so everything is cool there. Now we need to configure basic settings for each switch. Disable the DNS lookup. Configure the device name as shown in the topology. Assign class and encrypted privilege exec mode. Okay, so let's start. This is step 2. Right, so if I open okay, so if I go to my switch and have a look, I think it's finished reloading. Okay, so would you like to enter the initial configuration dialog, yes or no? Now when you see this statement, you already should know that, okay, there's no startup configuration on this switch. So no here. If you say yes, it will just go through the, for example, asking few questions like a wizard. It will start a wizard. So as you can see, the default name is switch and we are in user mode. So we need to type enable to go to the privilege mode and config T, and we're just going to change the name. So host name S1. Right, so if we look what else we have to do. So disable the DNS lookup. So the command to disable the DNS lookup was no IP domain lookup. Okay. The next command says configure the device name as shown in the topology. Already we give it S1. Assign class as the encrypted privilege exec mode password. Okay, so enable secret that's encrypted password. What else? Assign Cisco as a console and VTY password, and enable login for the console on VTY line. So we have to go to the VTY line. So line and console 0 password Cisco, and we enable login. Then I have to, well, I don't have to exit, but I exit from there. VTY 0 to 4, I can directly go to the line VTYs. Password Cisco, login. Okay, exit from there. Or exit. Let's just exit first. What else we have to do? Configure a login synchronous for the console line. So I have to go to the console line again. So line console 0 login sync, right? This is with 2 Gs. What it's going to do is going to synchronize your login. So if there's a message coming from the switch or the router, it's not going to interfere with what we type in. Configure message of the day banner to warn the users for unauthorized access is prohibited. So we can say exit from here and say banner MOTD, and then we start with the character. So say we start with a $, and we say authorized user. Let's spell it correctly. Authorized users only. Okay. Now what else we have to do there? Configure an IP address as listed in the address table, and then in the end we copy and run in config. So we have to go to the table and look at the IP address. So switch 1, the IP address on VLAN 1 is 192.168.1.1. Okay, so interface VLAN 1 IP address 192.168.1.1, and no shut. And then we copy running config to startup config. So copy running config to startup config. Right. So all that configuration is done for the switch 1. The best way to do this configuration is, instead of just doing one by one like this, you can just do once only, and then let me just open a notepad and show you. Right, so instead of just doing one by one, I can just do once, and then let's do for switch 2 first now. Disable everything will be from the global config. No IP main lookup. Configure name, so host name S2. Assign a class encrypted privilege exec mode, ever see there. So enable secret class. Assign Cisco for the console and VTY password. So I'll just mark line console 0 password Cisco login, and then login sync as well. Then I'll go to the VTY, the line VTY 0 to 4 password Cisco login. Okay, and then we can create the banner. So exit banner MOTD, and then authorize users only. Okay, and give an IP address. So if you look at the IP address, this is for switch 2 now. So that's the IP address. So if I just open my notepad again, a little bit. Okay, this will be on the interface. So make small gap. Interface VLAN 1. Give an IP address. IP address 192.168.1.2, and the default subnet mask. No shutdown. Okay, done. All I have to do now is highlight all this, right click, copy, and then go to my switch and switch 2. So this is switch 1, so Control Shift 6X to go back to the access server, and switch 2 is on the second session. You can see there's no configuration there at all. So enable config T, and then I'm pasting all that. Right. So you can see that that's an error there. I copied that by mistake. You can see no other errors. Everything seems to be fine. I've got switch 2 there as well. Okay, so if I open my notepad again, and instead of just change a few things here, this is for switch 3, host name S3, so I don't have to type. You see, the notepad helps you a lot. So, right, done. You can just copy all that again. And now I'll go to switch 3 and paste that. Now here, enable, config T, and then paste it. So just right click to paste it. Okay, as you can see, the host name has been changed nicely. It's got a password and got an IP address. Good, good, everything's fine. Okay, so verify that switches can ping each other. Can switch 1 ping switch 2? Okay, so we have to go to switch 1, so Control Shift 6X and then 1. Now I'm switch 1, show IP interface brief, so I'll just see the interfaces. What I'm interested in is in this one, VLAN 1, and it's got an IP address, status is 1, up, protocol is up as well. Okay, so I can say ping 192.168.1.2, and if I can ping it, great. So switch 1 can ping switch 2. Again, because I'm using remotely, so your picture might be flickering a little bit, but hey, with the switches, you have to be working on the physical switches really. Now, can switch 1 could ping switch 2, so I can type yes there. Can switch 1 ping switch 3? So I have to go to switch 1 and try ping 192.168.1.3. Switch 3. And yes, switch 1 can ping switch 3 as well. So I'll type yes there as well. Can move a little bit this way. Yes. Can switch 2 ping switch 3? So if I go to my switches again, Control Shift 6X, and I go to switch 2, and show IP interface brief. Okay, that's the IP address of the switch 2. So say ping 192.168.1.3. And yes, switch 2 can ping switch 3 as well. So I can type yes there as well. Yes. Troubleshoot until you are able to answer the yes on all questions. Well, we didn't have to. Everything worked. So determine the root bridge. Every spanning tree instance, switch LAN or broadcast domain has a switch designated as a root bridge. The root bridge serves as a reference point for all spanning tree calculations to determine which redundant path to block. An election process determines which switch becomes a root bridge. The switch with the lowest bridge identifier or bridge ID, BID, becomes a root bridge. The bridge ID is made of the bridge priority value, an extended system ID, and the MAC address. The priority value can range from 0 to 65,535 and increments of 4096. With the default value is 32768. That's a default bridge priority. So deactivate all switch ports, configure connected port as a trunk, activate port 2 and 4 on switches and display the spanning tree. Issue the show spanning tree command on all 3 switches. The bridge ID priority is calculated by adding the priority value to extended system ID. The extended system ID is always the VLAN number. In the example below, okay, so let's just run the command show spanning tree. So if we go to our switches, so I'm going to do first on switch 1. So show spanning tree. Okay, so spanning tree for VLAN 1. The bridge priority is 32768. This is for this switch that we're talking about. Now, the priority is 32768, this switch. Sorry, 32769 here. 32768, the priority plus the VLAN 1. That's what VLAN 1 there. our MAC address, or switch 1 MAC address, is this one, yeah? Right, so this is our MAC address. So if I write down in Notepad, I just want to make sure that we actually got this information. So switch 1 MAC is that, right? But the root bridge MAC is that. So if I open the Notepad again, and I just want to write down the root here. Root MAC address is this. Okay, great. So let me go to switch 2 now. Show spanning tree here. Right. Now the MAC address of switch 2 is this. So this is the MAC address for the switch 2. So if I go to my Notepad, type S2, the MAC address is that. Right. Okay, so I'm going to go to switch 3 now and type show spanning tree. Show spanning tree. Right. Now that's the MAC address of switch 3. So let me just highlight it properly. Okay. Open Notepad and type S3 MAC address equals the MAC address this. So if you compare these, right, that's for the switch 1, the MAC address. Let's go back to it like that. And that's for switch 2, and that's for switch 3. You can see the root bridge is actually switch 1 because it got the same MAC address as the root bridge. They all report the MAC address of the root bridge is the same for all of them, right? So switch 1 is our root bridge. Show spanning tree, and it says here this bridge is the root bridge, or is the root port. Okay, so the information here that you can see in yellow on our lab, it's about the information about the bridge where you're running this command, show spanning tree. The information that you see here, it's about the root bridge. So if it doesn't say this is the root bridge, it's not the root bridge. And it has to MAC address here of this bridge has to be different to this MAC address, because this MAC address is the MAC address of the root bridge, and it will display the cost. How much does it cost to get to the destination? If it's a root bridge, it will say there that this is the root bridge. Yeah, so this will be like this is, and so on. I don't want to change it here. Okay. So for us, I mean, I can't write it here, but we saw the MAC address. I did write it in Notepad. So the MAC address here of the switch 1, the MAC address of the switch 2, and the MAC address of the switch 3, and who's the root bridge. So for us, it was the switch 1. So it's going to be different to yours and different to the lab here. Might be different, might be the same, but that MAC address definitely is going to be different. Okay. Based on the output from the switches, answer the following question. Which switch is the root bridge? Well, we just found out that switch 1 was our root bridge, so S1 here. Why did the spanning tree select this switch as the root bridge? So if we go back to our, right, so all of them, they're going to have the priority 32769, which is 32768 plus VLAN 1. So if I go to switch 2, for example, show, if I just up arrow, repeat the command, you can see that all of them have the same, because I did not configure anything. So if you had left them to default, they're going to have a default priority 32768. So that wasn't a question. So the next tiebreaker, we looked at the MAC address and they compared the MAC address, and the MAC address, the lowest MAC address from switch 1 and switch 2 is switch 1. Well, all three switches first, but the first is 0, yeah? The first digit they're going to compare is 0. So that's not a tie break. Switch 1, the second digit is same as well. Okay, that's good. Then we look at the third digit. 1 here, that's still a tie, but 2 here. This already loses, goes. Then we look at this, the next digit. 2 is much lower than C, right? A is 10, B is 11, C is 12. So 2 is a lot lower than 12. So that's why switch 1 has become the root bridge, because we look at the lowest MAC address. So why did the spanning tree elect the switch to be the root bridge? Because of the low MAC address. Okay, which port are designated port on the switch? So if I go to my root bridge, which is switch 1, show spanning tree, and you can see all the ports are designated ports. Okay, I had to change it a little bit because one of the links wasn't working. So this is the location anyway. This is how connection between all the 3 switches. Switch 1, 2, and 3. Now switch 1, I'm just going to copy this and make sure that this, we know this is our root bridge. So root bridge. Root bridge. Now all the ports in our root bridge are designated port. So we go to switch 2 now and find out which port is going to be the port that's connecting faster towards the root bridge. So if I go jump to switch 2 here, okay, show spanning tree, and you can see the root port is FA011, right? So that port is my root port. So if I open, and this one has been chosen as a root port, so I'll put it in red here so we know that's my root port, right? What about switch 3? Which one is the root port on the switch 3? Right? You can see that port 12, it's blocking, right? Okay, so let me just put port 12 in red, so we know that's going to be bold and red, so it's blocking, and this one is going to be in green because of my root port, right? Let's use that. Okay, right. So port 11 is our root port, port 12 is blocking, and port 7 and 8, just normal, they are still forwarding. What about switch 3? If I go to switch 3 and do end here, show spanning tree. Now switch 3 has chosen port 8 to be the port 9 to be the forwarding and my root port. Port 10 is blocking, right? So if I go to switch 3, this one, it's green and it's my root port. 10 is red, it's blocking. And my red port. Now, how about port 7 and 8? What's happening with port 7 and 8? Port 7 and 8, they are blocking, right? Port 6 is probably connected to some other device. Well, port 7 and 8 are blocking. Let me just, if we don't know, show CDP neighbor, right? So only 7, 8, 9, 10 are connected to the switches. So that must be connected to end device. So port 7 and 8 are blocking as well. So if I go to my diagram, port 7 and 8 are in red. They are blocking. So we have a topology like that. Only 9 and 11 are forwarding. 7 and 8 are blocking. So in reality, if I delete this, yeah, if I go boom, that's link is deleted because it's blocking. This link is deleted because that port is blocking. This link is deleted, that port is blocking, and this link is deleted, that port. So there's no loop at all. We don't have a loop here. If we only enable this port and this port to be forwarding, all other ports to be blocking, because this is blocking this link, this is blocking this link, there's no loop. Loop-free topology. Right, let me bring back the port. Right, okay, so next task. Which port are root ports? We found that out. Which ports are designated ports? Which ports are showing alternate ports and currently being blocked? We looked at that. Why did the spanning tree select this port as a non-designated blocked port, right? So why, the question is, why these are blocked, but not these ones, right? If you look at the link, it's exactly the same. The first thing that we're going to see, the cost. Does this port has a faster way to get to the destination or this port? They compared it, it's exactly the same, the cost. The next thing they're going to compare is the priority. This switch and this switch, they're going to compare the priority. Priority was the same, left the default. And then they're going to compare the MAC address. So if they compare the MAC address, so if I open our MAC addresses again, have a look, switch 2 and 3, they're going to compare the MAC address. Switch 2 is going to beat switch 3 because the third digit is 1. Switch 2 and the third digit on switch 3 is 2. So switch 3, 2, 1, that election. That's why switch 3 is blocking the ports. Okay, observe the spanning tree port selection based on the port cost. The spanning tree algorithm uses a root bridge as a reference point and they determine which ports to block based on the path cost. The port with the lower path cost is preferred. If the port costs are equal, then spanning tree compares the bridge ID. If the bridge ID are equal, then the port's priorities are used to break the tie. Lower the value are always preferred. Now, the question is, why port 11 and 12? Why did 11 win? It's exactly the same. Everything, the bridge ID, because they are fast Ethernet interfaces, they are the same. The bridge ID is the same. Everything is the same. So in the end, okay, well, the only thing that we can differentiate between these two is the lower number. 11 is lower than 12, so that's why that one became the root bridge, or root port, sorry. For example, we look at here, FA011 is root bridge, better than FA012. So if we want to make sure that FA012 is a root bridge, then we can lower the cost. So config T, interface FA012, and then switch port, spanning tree, cost 18, for example, just lower 1. And then we do show spanning tree VLAN 1. And we can see now FA012 has been chosen as a root, while the FA011 has been alternate, has been blocking now, right? So the first thing we can think of it is the cost. How much cost to get to the switch root bridge? So the bolt, by default, they had a 19. So that was 19, like this. So cost 19 to go this way, like that. And this way. So the bolt had cost of 19. For that reason, it chose 11, lower number. Now when we change this to cost of 18, now this will become red and this will become green. So this will become red and this will become green. That's our root bridge. Root port. Why? Because it's got lower cost. When we change the cost back to what it was, then obviously it's going to change back, right? So we're going to change this back to 19. Okay, so let's have a look again at our switch. Now you can see it's going through listening, went through learning, now it's forwarding. It's root port. The reason is because it's got a lower cost. Right, so now the next thing we're going to do is we're going to put it back. So interface FA012, no spanning tree cost. Okay, show spanning tree, same. So it's going to revert it to back. Right, this is blocking now, and this is going through the transitions, listening, then go through the learning, and so on. Right, let's just wait till it's learning. Yeah, learning, and then it will go to forwarding. Okay. Next, observe the spanning tree selection based on port priority. Right. So when we look at this way, right, we can have a look at this port priority as well for choosing the root bridge, right? See the priority here? Port priority is the same, 128, 128, 128, 128, right? We can change that port priority to affect the spanning tree root port selection. So we can see the root 11 is our root port, right? But the port priority depends from the neighbor more than from yourself. So we can change it here, but it's not going to have that much effect. So if I go to interface FA012 and say spanning tree spanning tree, question mark here. See this one here, port priority. So let's change it. Port priority and increments of 16. Okay, so let's just say 16 and show spanning tree. Right, you can see now it's 16, but it hasn't affected anything. This port priority is more to do with what you tell the neighbor. So if you want to influence the neighbor rather than yourself, right? So even though we changed it here to 16, hasn't done anything. So okay, let me change it back. So config T, interface FA012, spanning tree, port priority, and just put no, and that's going to revert it. Okay, show spanning tree. As C has gone back to 1 to 8. Nothing has changed. Okay, so what we're going to do is, what the important thing to know is the priority. Okay, so let me just copy this, and the priority, port priority, default is 1 to 8, but is what you tell in the neighbor, not what is yours. It's what you are telling the neighbor. Yeah. Right. So because they both have port priority 120, so both sides 120. 128. I'm trying to like if I can fit them both. Let me just maybe move this one bit down. Now what we're going to do here is we're going to change this port priority what we tell our neighbor. So it has to be increments of 16. So let's put 32 and try and influence this to be our root port, not this one, by just changing on the root bridge the port priority of this port, right? So I'm going to go to my root bridge now. So that's our root bridge. Show spanning tree. Right, so what I'm going to do is I'm going to go to this port 12 and change this port priority to 32 and try and influence my neighbor to change the root port. Okay, so config T, interface FA012, spanning tree, port priority, port-priority, and just 32, and show span. Okay, it has changed. Right. Nothing has changed here. Let me just go to my neighbor, which is switch to show span, show spanning tree. You can see now the neighbor's root port has changed. The 12 has become the root port and is learning, while his 11 is blocking now. So by just changing the priority on the root bridge, we affected this to become our red port now. A red port. We haven't changed anything, just port priority on the root bridge, and we have affected our neighbor to change the decision, to make a different decision. Now FA12 is our root bridge, and FA011 is our alternate port. Okay, so that is showing you how to change the port priority. This has been Asterix Ratnishi demonstrating you how to configure a basic spanning tree calculation, like find out why is a root bridge, who's a root bridge, and change few things so we can manipulate our election of root port, designated port. So for example, our root port was 11 by default because it was lower than 12. We changed the cost of 12 and that became the root port. Then we reverted everything back and we went to our neighbor and changed the port priority and to effect which is our neighbor's root port as well.